It's easier to find the LCD, exactly. So if you factor, so step 1, factor. But what was that other step we like to put in the middle now?
Domain.
Find the domain, and then find the LCD. So in the green, it's factored. So what is this right? What is, sorry, I moved a little bit. What's this? That's the LCD.
Yeah.
Things nicely cancel. You just have to be really careful. You have to be careful with the algebra. All of this right here is just what? Algebra. We've managed to get rid of all the nasty denominators. So all you have left is algebra. You have to be really careful. But what's nice is if you simplify, you end up with a quadratic equaling 0. And what's nice, is this nicely factorable? Yeah. Yay, it's nicely factorable. Now theoretically, it's not done on this one, but theoretically, can someone tell me, using the green right there, can someone tell me what the domain is? X such that x does not equal -3 or what? 1. Let's go down here and look at our answers. So do both of these work?
Yes.
Theoretically, if you've done our algebra, what you would theoretically do is take those numbers and plug them in just to make sure you didn't make a math mistake. But the idea is, are those numbers in the domain? Yes, they are.
So if you find the domain, you don't have to like plug it back in?
No, I'm saying that it's a good sign, but it's not sufficient.
Okay.
It's necessary for the numbers to be in the domain, right? But theoretically, you just have to make sure that they work, right? Like theoretically, I could have done totally wrong math and come up with the answers 78 and 52 billion. And like, guess what? They're in the domain, right? But do they necessarily make the equation true? Not necessarily. Does that make sense? Yeah. Cool. Long division. What type of long division are we going to do? There's a name for this. Eventually synthetic division. We can't use synthetic here. But what's this going to be called? We're going to divide. It's going to be what kind of long division? Polynomial long division. The rules are almost identical to long division. You're going to take what you're dividing into, x squared plus 2, and then you're going to make a little thing like this. Exciting. And then you're going to do x to the 4th plus 2x cubed plus 3x squared plus 4x plus 2. There's already one thing I did. What's the one thing besides copying that down? What did I do, Maggie?
Put it in descending order.
In descending order. Please put it in descending order. Please, please, please. Also, if there were like terms, what would you do with those like terms? You would combine them. You would combine them. There's really only one phrase you need to remember when you're doing polynomial long division, and it is the phrase leading over leading. Leading over leading. You're going to use this phrase over and over again. This is also an algorithm. You're going to do the same thing over and over again. What's the leading term for the thing underneath the division? X to the 4th. What's the leading term of what I'm dividing into it? X squared is the term. I keep on doing that, I don't know why. X squared. What's x to the 4th over x squared? So you take that x squared. Where do you put that x squared, do you think? On top, over where the x squared term is. Now you do the same thing you would normally do in long division. When you put a number up there, what do you do with that number? You multiply it into both of these. What's x squared times x squared?
X4.
Ah, it better be the same. And what's x squared times 2? 2x squared. Here's something that's super important, and I can guarantee you're gonna hit this, and sometimes it's going to cause massive problems. What do you do now?
Minus.
You subtract, exactly. This is what I'd like you to make sure you do. Draw the line, put parentheses around the whole line, and put a minus sign up front. The most common place by far that kids make mistakes in this is right here. They understand the whole system, but then they subtract wrong. It's really disappointing sometimes because you get really sad and you're like, why don't I get this? And you get the process, but you need to avoid failing at the subtraction. So if we subtract this, what's x to the 4th minus x to the 4th? 0. What's 2x cubed minus 0x cubed? Come on, not a trick question. 2x cubed, yes. And what's 3x squared minus 2x squared? X squared. What was that phrase I told you need to pay attention to? Leading over leading. What's the new leading term? Nope. Please tell me the whole term, Danny. 2x cubed. And what's the, oh, this leading term stays the same the entire time. What's the leading term there? What is 2x cubed over x squared? 2x. So we have plus 2x. Hey, do you just do the same thing again? What's 2x, Liana? What's 2x times x squared?
2x cubed.
Yeah, and then what's 2x times 2? plus 4x, like this. And remember I said you do this every single time, put the line in the subtraction. Do you see how I brought that 4x down? Oh, I didn't bring it down yet. That's the new one. I've got to bring down the 4x, sorry. Bring down the 4x. If I subtract right now, what happens? What am I left with?
0.
No, I am not. Danny, you need to raise your hand and also count in your head to at least 5 before you speak, okay? You cannot just keep on shouting out numbers. What's left? Yes? X squared is the one thing that's left, because what happened to the other two terms? They become 0. What do I drop down now? Plus 2. What's the new leading term? X squared over what? Yeah, that's the x, and what's that equal? 1. So where do I put that 1? Put that 1 up here, and now I multiply, and what do I get? Plus 2. And what do I do? Hey, when I subtract, what does this become?
0.
Is that awesome? That means what? What does it mean when you have a remainder of 0? It is a factor. X squared plus 2 is a factor because the remainder is 0. 2 is a factor of 6 because when you divide 2 into 6, what's the remainder? 0. If you don't get 0, which is possible, it's not a what? Not a factor. We love zeros. You're going to spend a lot of time searching for zeros. You do that in algebra, pre-calculus, lots of times in calculus. So what does that now tell us? It tells us that we now have x squared plus 2 times what? Equals our, if this is p of x, is times what? X squared plus what? Equals our polynomial. Are we done yet? No, because what can we factor right there? So what do you end up with? X squared plus 2 times what? X plus
1
squared. This right here is the fully factored form. That is p of x, the original polynomial. We were able to start, though, because what did this thing give us? What did it give us? It gave us something super helpful, knowing that this is a factor. Is that super helpful? Yes, it is. So this is what I'd like you to do right now. I'd like you to find a part of the board with a partner, and please factor this using polynomial. The power is 1. You can use something called synthetic division. Here's what the setup is going to look like. Tell me where I got each piece from. The setup is going to look like this. I keep on moving this with my, there we go. Let's do this. We're going to have 5, 1, -3, -14, 12, and 40. Where did those numbers come from? So the ones up top, these are what? These are coefficients of the polynomial. 1, -3, -14, 12, and 40. Where did the 5 come from? Yes, x minus 5 equals 0, x is equal to 5. 5 is what makes the factor equal 0. What makes the factor equal 0? Synthetic division is also an algorithm. You do the same thing over and over again. Anybody remember what the first thing you do is? What's the first thing? Yeah. You bring down the first term. So we're going to bring this down. It's a 1. And then you multiply by 5. So let's multiply by 5. And what do you get? So you multiply by 5 and you end up with 5. Now what operation do you do? Do you remember? Not subtraction. You add. So what's -3 plus 5? 2. And now you just do the same thing over and over again. 2 times is 10. 10 plus -14 is? 5 times -4 is? Add them together and you get -8. -8. -8 times 5 is? And when you add them together, you get 0. Again, is 0 your friend? 0 is your friend. Here's why this is super, super helpful. Here's why this is super helpful. All synthetic division does is evaluate polynomials. What does this mean? It means when you plug in 5, what do you get out?
0.
When you plug 5 into this big thing right here, you will get out 0. It confirms that this is a 0. Here's the thing. We don't know what the other factor is right now. We know that x minus 5 times some polynomial equals this big thing right here. Like this. Wow, it's super long. Yay. Right now, we don't know what this is, but here's the thing. What happens if I plug in 5 right here? What does this become?
0.
What is 0 times anything? 0. 0 times anything is 0. Synthetic division tells us that when we plug in 5, we get 0 on both sides, so that this is a factor. Finding factors and finding zeros are the same thing. If I tell you that 4 is a 0, what's a factor? X minus 4. 5 is a 0, so x minus 5 is a factor. Rational zeros. Very nice. Here's the thing. We still want to find this, right? So theoretically, we could do polynomial long division, but there's something magical that synthetic division does. P of x is actually staring you in the face. Can anybody see what P of x is? What is it, Maggie?
It's x cubed plus 2x squared minus 4x minus 8.
Does everybody see what I'm writing in here, starting with the right? The constant is the first term that isn't 0. So P of x is actually, can someone tell me what it is? 1x cubed plus 2x squared minus 4x minus what? 8. So we now have x minus 5 times x cubed plus 2x squared minus 4x minus 8. If I don't give you any hints, if I give you no hints and I tell you to factor a cubic, what's the only method you have right now to factor a cubic? If I don't tell you anything else, grouping is the only thing you have. So if grouping doesn't work, just stop. But if you see a cubic and I give you no hints, right now what's the only thing you can do? Grouping! And in this case, does grouping work? It does. What do we factor out of the first two terms? What do we factor out of the first two terms? Mikey?
X squared.
X squared. So you end up with x squared times what? Plus 2. And what do we factor out of the next two? Minus 4 times what? X plus 2. Oh, so what does it factor into? X minus 5 times x squared minus 4 times 2. Are we done?
No.
What is this right here?
X plus 2x minus 2.
Yes, the difference of squares. So this is x plus 2 times x minus 2 times x plus 2. So are there 2x? Oh, there's 2 of them. So what do you end up with? X minus 5, x minus 2 times?
X plus 2 squared.
Boom. Fantastic. We love that. That is excellent.